Hi and welcome to Geeks for Geeks. Can I have a quick plus one in the chat if I'm visible as well as equally audible? Just a quick plus one in the chat. Then we would start right away. Let me see if I'm visible. Yeah, I'm completely for now I'm visible as well as audible. Let me refresh my screen and see. Audible. Plus one in the chat. Then we would start right away. Okay. So we are visible as well as equally audible. So let's start. So today we would be discussing the problem of the day. Okay. Let's wait for a few moments so that everyone joins. Okay. We would be waiting for 1 minute, 1 or 2 minutes at max. Okay. So that everyone joins. Okay. Okay. Let's start. So can I have a quick plus one in the chat? If I'm visible as well as equally audible. Let me lower down the preview. Yeah, good to go. So today we would be discussing the problem maximum XOR subarray, and it was a expert level problem, but it was mentioned medium, and it was asked in Microsoft, and it has a percentage success rate of 47.34. Okay, so we would be solving this problem. Okay, if you face any frame drops or any difficulty, just let me know if my audio is not audible, because in the live class there is a lot of difficulty. Okay, let's start. So today we are given an array ARR of size n, and we need to find the subarray with maximum XOR. Okay, a subarray is a contiguous part of the array. Okay, now here. So at first, so solve this problem, we are given an array of size n. So this we know. So then we need to find a subarray. Now what is subarray? Subarray is a contiguous subsequence. What is subsequence? Subsequence is a sequence which, suppose the elements are 1, 2, 3, 4, and 5. Let's make the brackets to distinguish between the elements. So a subsequence can be 1, 3, and 4. It can be a subsequence, but 3, 2, 3, 2, 3, and 1 can't be a subsequence. So it should be in the same way as it is appearing in the same thing. Good to go. Now we would be moving forward. Now what is subarray? Subarray is a particular part of the array. Continuous subsequence is known as subarray. Okay, in the subsequence, if we skip some elements and take out the resultant element, then that would be a subarray. Okay, and we need to find a subarray which has maximum XOR. Okay, so understand how can we get the maximum XOR. We first need to learn what is the truth table of XOR. After that only, because to solve any of the bit related problem, at first we should know the truth table of that. Okay, at first we should know the truth table. Okay, moving forward, the truth table of XOR are same when the two bits are same 0 and different 1. Okay, just remember this and you would be good to go in all XOR related problems. Okay, if in all XOR related problems you would be good to go. Good to go. Okay, now if the same bit are same like 1 1 or 0 0, then that would be 0, and if they are different like 0 1 or 1 0, then that would be 1 itself. Okay, so am I clear till this point or not? What is subarray, what is the truth table of XOR, and what we need to do? Am I clear till this point or not? Can I have a quick +1 in the chat so that we would proceed? Okay, because understanding the question is more important than solving it, because telling you the solution, and if you don't get the question only, then you won't be able to apply this solution to any other question. Okay, because this same question won't come, question like this would come. So am I clear till this point or not? Can I have a quick +1 in the chat? Okay, I got 1 +1. Can I have 1 crore +1? Then we would proceed. Only one has understood for now. Okay, 2 has understood. Okay, so we would be moving forward. Okay, let me remove the annotations. Okay, so in bit related problem, the first thing that you should do is never consider this array. Never consider this. What I generally do is I convert all these numbers in binary representation. Okay, if we convert all these numbers in binary representation, then it would be easier to analyze. In this question, it won't be of much value, but in other questions like this, it would be of much value. Okay, here it won't provide much value to it, so I won't be doing this. And to tell you, explaining you the test case would be a waste of problem, I think. So I would be moving ahead because that won't be much useful one, because I think you have already understood the question. Okay, let me clear all this. Okay, so the first thing that you should know is, suppose there is a XOR. Okay, suppose there A1, I won't be writing A1, A2, A3, A4 and A5. Okay, you have this, and there is an interesting thing about XOR. Okay, so I think that if you are attempting to solve this, I personally take that you already know about the prefix sum or suffix sum. Do you know that? If you know that, just give me a +1. If you don't know that, say that you don't know and I would be explaining that. Okay, but I suppose that you have already, if you are solving this kind of question, then you already know prefix sum or suffix sum. Okay, but then also I would be explaining in brief what is prefix sum and suffix sum. Okay, because that idea is important. Okay, so at first it would be like, what is this? 1 3 1 5 and 4. Now what is the prefix sum array? Prefix sum array is nothing, just 1 plus 3 is equals to 4, 4 plus 1 is equals to 5, 5 plus 5 is equals to 10, and 10 plus 4 is equals to 14. This is the prefix sum array. And why this is used? This is used to take out a particular range of sum of particular range. Okay, subarray. So how can we take a particular? We know that till this point the sum is 10, and before this the sum was this one, because this was outside this. So 10 minus 1 would give us the value itself. This thing is used. So suppose we want to take out the XOR. in the same fashion like we have just calculated prefix sum. Okay, so it is a common practice that if we calculate, suppose the value here is a, b, c, d and e itself. Okay, am I clear? So I am clear till this point, I hope. So suppose you know that XOR till this point is d, okay, and XOR till this point is b, okay, and you want the XOR of only this range, okay. So what you can do is you can simply do XOR d XOR b, and it would give you the XOR of the remaining values, okay, and it would give you that, okay, whatever be the value. Suppose it is x itself. Moving forward, so I think I'm cleared with this. So this concept would be used in this question, okay, where and which point I would be telling you. But before solving a particular question, why were you not able to solve this question? You were not able to solve this question. There might be of two reasons. First, you forgot the concept, or you don't remember the concept, or you don't know the concept. So if you don't remember or you don't know, in both the cases you need to either learn or revise. So I am doing a quick crash, okay, I am doing a quick recap of what facts and figures should be known about XOR, okay, to solve this question. So it would be refreshed in your mind, and those who don't know, they would learn it, okay. So let us move forward. It is fine till this point. Moving ahead, suppose we want to take out, I'm extremely sorry, the open board just crashed. Okay, so the thing is that, the particular thing is that, wait a second, I'm sorry, I can't help it. Actually, OBS and open board are working at the same time, so it just crashed. Okay, so the first thing that comes to our mind is, what we can do is, suppose the array is a1, a2, a3, a4 and a5, okay. So what we can do is, the subarray would be, suppose the value might be this, the value might be this, okay. So what we can do is, we can simply point at a particular position and then move from this position, and then again point at this position and move till this position, okay, and take out the XOR, and we do a maximum value and we store the maximum value, okay. So we would be using a for loop for the selection of elements, and again a for loop for moving ahead, okay. This for loop would be used to take a start, and this for loop would be used to calculate. Good to go. So what would be the time complexity of this solution? If we use two nested for loops, what would be the time complexity of this solution? Tell me, what would be the time complexity of this solution? And here we would be taking account of the answer is equals to max of answer comma temporary answer. Good to go. The same old thing. So tell me, what would be the time complexity of this solution? I would be waiting for just 1 minute. Those who are attending my class for the first time, they might not be acquainted with this way of mine, way of mine, but that is my way, so that you would know till how much I would wait, you would get an approximate value too, okay. That's why. Okay, big O of n square. Anyone else who thinks that it is correct? The answer would be big O of n square. Tell me, anyone who knows? And then, okay, good to go. N square. Okay. Okay, good to go. Congratulations, Jaydeep, and congratulations, Ankita. You two have, okay. The complexity of this solution is big O of n squared. Now, one thing, so in 1 second, there is a thumb rule that in 1 second, we can perform 10 to the power 8 operation. Good to go. And the upper bound of n is 10 to the power 5. Okay. And the upper bound of n is 10 to the power 5. So 10 to the power 5 square would be 10 to the power 5 into 10 to the power 5. Base are same, so the powers would be added, that is 10 to the power 10. 10 to the power 10 is much greater than 10 to the power 8, so we would require around 10 to the power 2 seconds more to 2 second approximately this to compensate upon this. I shouldn't be writing this. Yeah, good to go. So this won't fit in the time limit and you would get a time limit exceeded. Okay. So this solution won't pass. So we need to give a solution which would work in n big O of n or big O of n log n. These all popular time complexity solution would be there. Okay. So moving ahead, how can we solve this kind of question? Okay. So take a pen and a paper and try to do something. Okay, try to work upon the sample test case, try to give up a sample test case, and you would find a way that what we can do is suppose this is a1, a2, a3 and a4 and a5. Okay, I generally don't do this on a pen and paper, because if I do the rough work here, it would help you to understand and it would be crystal clear on your head, but it would have a adverse effect on the time limit of the teaching mind. Okay, and the lecture would be very long. Okay, that's why sometimes I tell that do this on a pen and paper and you would come to the conclusion, and I take out that you have already tried this. Okay, so moving forward, suppose what we can do is we can take till this point. Okay, we can calculate prefix XOR we can calculate. Suppose this is A, this is B, this is C, this is D, and this is E itself. We can calculate like this. Good to go. And if we take this position as the end point, listen very carefully. If we take this position at the end point, then what we can do is we can simply remove this or remove this or remove till this point, and we can come at different conclusions. Okay, let me erase this. Yeah, good to go. So I am telling you the idea once more. What you can do is you can stand suppose at this position. Okay, and this position, suppose the answer is D, and if you do D XOR A, it would give you this value, and if you do D XOR B, it would be giving you this value. Okay, let me change the color. Okay, and if you do D XOR C, then this would give you this value. So am I clear till this point or not? What I am trying to do? How to take out different subarrays by doing this thing? Am I clear till this point or not? Just tell me if I am clear till this point or not. Then we would move ahead with our idea. And is this trivial or not? ऐसा क्वेश्चन आया तो तुम सोच सकते हो कि नहीं? ये पॉसिबल सोचना है कि नहीं? The main problem which I faced in my initial years was I was always concerned that ये idea मेरे दिमाग में कैसे आएगा? The general query, how to think like this, how to think in this way. Okay, good to go. Moving ahead, we would see that we need to do a XOR of this. So taking out the XOR till this point, this point, this point will take big O of 1 because we have already pre-calculated the prefix XOR. Okay, good to go. So yeah, good to go. Yeah. So even if we stand at this position and compare the values here, 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 it would again be a n square solution. Okay. So we need to optimize upon this. Okay. To optimize upon this, we need to look at the truth table of XOR. Okay, which I had already written. That same 0, different 1 itself. Good to go. So moving ahead, we would move ahead and we would see that suppose at this position our answer is 1 0 1 1 0. Good to go. So what we can do, what do you think? Okay, so we need to take some values and do a XOR with this. And what would be this value? This value would be A, B, C, D. Okay, so tell me what should I do to maximize the answer? This is what we need to do, na? Suppose we take this as the endpoint. Okay, now we want to take out that if we take the endpoint as this, what would be the maximum XOR value? And to take out the maximum XOR value, what would be this value, so that this answer should be maximum? What should we try to do to maximize this answer? To maximize this answer, what should we try to do? Take the help of the truth table. This is a clear hint that take the help of the truth table. Okay. Now I would remove the unnecessary parts. I would write all this. I would write all this again till you are thinking. Okay. Because this is important. A1, A2, A3, A4 and A5. Then A, B, C, D and E, which would be the prefix XOR, and this would be the array itself. Good to go. Then we would be moving forward and we need to maximize upon this. To tell me how can we, what should we try to do to maximize this? Suppose this is our value. Suppose this is our value. What should we do? What should be the value at this point so that we can maximize this? Tell me. I would wait for 1 minute. After that, I would be explaining you. Try to set the leftmost 0 bit. Yeah. You are going absolutely correct, Jaydeep. But can you generalize your approach? It would work for the last bit. But can you tell me what would we generally do? Yeah. 2. So what we should try to do is, suppose the bit is 0. Okay. So we should try to find a bit which is not 0. Okay. We should try to find a number whose last bit is not 0. We should try to find a number whose last bit is different than this bit. If we find 1 and 1, then XORing both of that would give you same 0. So value would be 0. And it would make the value small. But we need to maximize our value. So we should try to find a value which would be different. We should try to maximize. We should try to find a value which has the most different bits than this one. Else, if we can't do that, we would try to be with the same bit. If we try to find the different bit, then the value would be 1. Okay, and it would help us maximize our answer. Okay, till this point, we can calculate the prefix XOR, and till now we have known that we need to search upon our answer. Good to go. So suppose if there was a dictionary which would contain all the prefix values till this point, then what we can simply do is we can simply search that last value whose bit is different, prioritize it. In a second, whose bit is different, prioritize it. Third value, no bits are different, prioritize with the same bit. So fourth value, no bits are different, prioritize with a different bit. No bits are different, give a different bit. Bits are not different, give it the same bit. If we had a dictionary which was fast enough, can we do that? Can we implement this solution in big O of n? If suppose we devise a method, XORing would take big O of 1, and that method would take big O of 1. So big O of 1 won't be of much use, and traversing this value would be a big O of n. So our solution is fast. Now we are mainly concerned about building a dictionary fast enough. Okay, moving ahead. Now we need to build a dictionary fast enough. So whenever we see that we need to do a pattern matching, or we need a dictionary which is fast enough, we take help of try data structure. Okay. Now, how would you think that what would be helpful? You should have a proper vocabulary in your mind that if we need sorting at each position, then we should use priority queue. If the answer is a monotonous function, then we should use binary search. If we need a dictionary which is fast enough, then we need a try. If we need the particular range of sum and we need to update it also, we take the help of segment trees. Okay, and the next thing is that you should always keep in mind that XOR related problems can be solved using try. Okay, if you are stuck in a XOR problem and you are not able to come up with a solution, try to solve it using try. This is a common technique which many experienced programmers used. Okay, so am I clear till this point or not? Can I have a quick +1 in the chat? I'm trying so hard to join every bits and build up the solution. So at least I deserve a little bit answer from you all, just not from Jaideep Bose. Can I please expect an answer from everyone else too? If possible, I would wait for 1 minute. And then we would proceed if you have successfully understood till this point. Can I have a quick +1 from everyone else also? Because seems like I am only teaching Jaideep and Ankita. Can I have a quick +1 from everyone else also, please? If possible. Would be waiting for only 1 minute, so that I would get to know that if you are understanding or not, if I need to repeat or not, if I need to move ahead or not, if I need to move ahead speed or slow, what should I do with the speed of explanation? Okay, no worries, we would be moving ahead. Okay, so we need to implement a try data structure. Okay, so if you are not familiar with trying to solve a problem with try and teaching you try also would take us a very long time. So what we would, I only 2 are live, so go a bit faster. In my screen it is showing 8 are live. Okay, don't know. It might be the case they would see it offline, so I can't go. I need to go. So if you don't know about try, then what you need to do is you need to pause at this point, then you should go at learn try and then again come back at this position. Okay. Now I take that you have paused the video and successfully learned about try. Now we would be implementing it. Okay. So what we would basically be doing is we would be having a structure of 0 at this point, 1 at this point, and then again 0 at this point, 1 at this point, then again 0 at this point and 1 at this point, and then same thing 0 at this point and 1 at this point. We would do the same thing. Moving ahead. So we need to implement this try. Okay. Now what we need to do is the initial value should be 0. Why it should be 0? Initial value of all these nodes should be 0 because property of XOR tells us that XOR with any other element would give us X only. Good to go. That's why we would be initializing with XOR if we don't know the value. Okay. It would give us this value. So it would be safe enough. Moving ahead, there are two types of queries. At first, we would be inserting. Okay. So we would be looking at first to the insert function. Okay. At first, we would be inserting, then we would be querying. Okay. At it prefix, and we would be getting the maximum prefix and doing that maximum prefix. So that would be a query and inserting would be that. So at first, we would be dealing with the problem known as insert. Good to. So what would we do in the insert? We would at first everything would be initialized with a 0 itself. So we would go, suppose we need to initialize 0, 0, 0, 0, 0, 1. Okay, good to go. So suppose we need to initialize 0, 0, 1. Okay. Suppose we need to insert this in the try data structure. So what we would do is we would come at this position, then this is 0, then again 0, then we would come at this position. So this would be 0, 0. So we would be doing 0, 0, 1. And we would be doing the same thing everywhere. Okay. Now the next thing that remains is the query one. Okay. Which I showed. The same thing would be done at this position. If a pointer is null, then we would be producing a new node. Else it would be initializing with a blank and we would be just updating it. Good to go. Now, the next thing is the most important. That is the query part. Okay. Now, the query part, at first, we would check if the current bit is set or not. Okay, suppose the current bit is 1. So what we would do is we would try to go on the 0th bit. If it is 1, we would try to go on the 0th bit. If it is null, if the 0th side, suppose what we can do is, suppose the value is 1. If we go at this position, we encounter that there are no elements here. If there are no elements, it would be null. So we know that there are no elements. We can't find any element. So if we can't find any element, then we would again go with 1 only. We would go with the same element. Same if null. Okay. Else go with opposite. Okay. Else we would say that we would go at this position. And same thing would be this, and we would be querying upon this. And what would be the thing we would be doing? And what we would be doing is we would be having A1, A2, A3, A4 and A5 and XORing the values at this position. We would be traversing from here. We would take out the maximum value which would produce the maximum XOR it with that, and we would store our maximum answer. So is the pseudocode clear? Can I have a quick +1 in the chat? If the pseudocode is clear, then we would move to the implementation part. So can I have a quick +1 in the chat if the pseudocode is clear? Can I have a quick +1 in the chat if the pseudocode is clear? So here we have built a struct node which would store two values, two sides, 0, 1, 0, 1, 0, 1, 0, 1, same thing. And this value would be initialized with a 0 thing. Okay, then we would produce a new node. This would produce a new node and the value at first would be 0, and then both the ARR0 and ARR1 would be pointing to the null itself. Okay, and we would be returning the pointer, and this function would help us to make a new pointer and initialize with 0, make a new pointer and initialize everything with 0, make a new pointer, initialize everything with 0. Okay, the first thing that we would deal is with the insert operation. Okay, so we would take the root node and the prefix XOR till that point. Good to go. So what we would do is we would traverse from the back itself. Okay, and this OK value would become false or 0. Okay, so this is initializing 1 right shift, 1 left shift by I, and we would be and that would be 0 and 1, which would be 0 and 0. It is just to check if the particular bit is set or not. This is a particular practice which many to check if the particular bit is set or not. Okay, now OK would be true or false accordingly. Okay, now we would be checking that if that side, suppose we need to move towards this side and this side is null, so we need to make a new node at this position, then we would be putting the value in that position. So we make a new node and then we would be putting the value at the end, at the leaf node, not at this point. We would be traversing. At the end we would be initializing the values. So we need to traverse this, and then what we are doing is temp is initialized with the children, and at the end we need to point at the end. So this is a simple one. Good to go. Next we would be moving ahead with the query one. Okay, so we would be initializing with the root value, then the prefix sum, and temp is equals to root. Okay, then we would be moving from the back itself. Okay, good to go. So then we would do is we would at first check if a particular bit is set or not. Okay, and then and what are we doing here? 1 minus OK. So it would be like this. If this is 0, so 1 minus 0 would become 1. 1 minus 1 would become 0. So if we give a value 0, then it would be converted to 1. If we give a value 1, it would be converted to 0. Okay, so if the converted value, the opposite value, is not null, then we know that there exists an element at this position, so we would be going at that position. If it does not exist an element at that position, then we would be going at the same bit. Okay, if the bit is set, we would go at that position only. Then what we are doing is we are XORing with the last value and then returning it. Okay, now what we are doing is at first we are creating a new node, that is the normal thing, try data structure, and then we are initializing the root with 0, and then the answer is initialized with min n to take out the maximum value, and the prefix XOR at first would be initialized with 0 because of the identity property of the XOR. Okay, now the prefix of XOR would be a-i XOR. This we are calculating the prefix XOR and then we are inserting it. Okay, and after inserting at that position we are querying, because at this position the only element that would exist would be the element before that, not after that, because after elements are not processed, so it would be having the elements after that, so we would be searching for the element before that. Okay, and then we are taking the maximum value and then we are returning the answer itself. Okay, so am I clear till this one or not? Can I have a quick +1 in the chat so that I can take a leave, or if you have any queries regarding this, let me know. Okay, tell me, am I clear till this point or not? Tell me if I'm clear till this point or not, else we would be moving ahead. And if you face any difficulty in the implementation, or if you want a template of try data structure which we normally use in competitive programming, then you can contact me on LinkedIn. My username is Siddharth Hazra, Siddharthhazra. You can search me on LinkedIn and text me. I would be providing you the template. And if you face any difficulties in this question, or if you have any general doubts that you want me to resolve, and if you think that I would be able to resolve it, then you can contact me and ask me on LinkedIn itself. So can I have a quick +1 in the chat that I am clear till this point and I would take a leave? Okay. So I got a clear sir from Ankita, and no one else is asking any doubts. So I have waited enough. So I think no one has any doubts. So I would be taking a leave after this point. Okay. That's all for today. Thank you and have a nice day. Keep till then, keep coding.